Do you want to make a grid inventory where your items can do things like this? Well, look no further. Let me show you how it's done. So let's start by creating the main scene of our project, which is going to be a user interface. So let's click on user interface and it's going to create a control node. So let's call it main, and then let's add a panel container that is going to be our inventory. And then the child of this inventory is going to be a grid container that we're going to call item grid. Then let's give them a unique name. Access a unique name, and let's save this bad boy somewhere in a new folder that is going to be called scenes. So the next step is going to be to create something that we're going to populate our item grid with, which is going to act as our inventory slot. So let's create a new scene, and it is going to be of the type of a color rect, and let's change its minimum size to 16 by 16 in here in our custom minimum size in our layout drop down thingamajig, and let's resize it, reset its size to our minimum size, and then let's change its color to gray. Now let's create a child of this guy, which is going to be also a color rect, and we're going to resize it in our layout transform to 14 by 14. Now let's move it so it's centered, and let's name it inventory slot, and let's save it in our scenes. Now let's go back to our item grid and let's create a new script for it. So item grid, and let's create a folder here that is going to be called scripts. And let's place it in there. Now, first thing we're gonna do, we need a reference to our item slot. So it's going to be export var inventory slot scene. And we will also need another export variable that is going to be called dimensions. Dimensions that is going to be a vector to I. Now let's create our ready function in which we're going to call create slots function that we're going to create right now. Create slots. It is going to be a void, and the first thing we're going to do in this function is we're going to set our columns to our dimensions.y. And columns is a built-in member variable in the grid container class, which is this, which basically tells how many columns are going to be in that grid. So next we're going to loop over our dimensions. So for y and dimensions y, for x and dimensions x, we are going to instantiate our inventory slot from our inventory slot scene instantiate, and we're simply going to add child inventory slot. Now let's set dimensions to something like 4 by 4, and let's add our inventory slot scene in our inventory slot thingamajig in here, and let's run this and see what's gonna happen. And here we go. As you can see, we have a working grid. Now in our item grid, we need to do a very important thing, is we need to go to our theme overrides and constants and click on these check boxes, so our separation between our slots is 0 pixels. So now it looks like this, and it doesn't have this huge gap between each slot. So back in our item grid script, let's create another function that is going to be called func init cell data, and it is going to be void, and for that to work we need another variable that is going to be called cell data. You guessed it. And it is going to be array of nodes, and it is going to be empty by default. Now in our init cell data, we're going to resize our cell data by our dimensions x multiplied by dimensions y, and then we're going to fill our cell data with nulls. Now, what the heck is the cell data all about? Well, cell data is an array that is going to represent each slot in our inventory grid. So currently we have 4 by 4 grid, and each cell in here is going to be one thing in our cell data array. So let's go ahead and call this init cell data in here after our create slots in our ready function. Actually, I hate how inconsistent my naming is, so let's rename it to slot data, and in here also init slot data, and in here also slot data, and in here also slot data, and in here also slot data. Next, we're going to create a function that is going to help us to detect which slot we're clicking on. So let's call it get slot index from chords and it is going to take coords as a parameter that is going to be a vector to I, and it's actually going to be an integer as a return type because we're going to return the index of the slot. And the first thing we're going to do with this, we're going to subtract our vector to I of our self global position to make it relative to our position of our item grid. And then we're going to divide our coordinates by the 16, which is going to be our slot size. Actually, let's create a const in here and let's call it slot size. It is going to be an integer of 16, and let's change it to slot size, just like so. Now let's temporarily return 0 in here, and let's print coords, okay? And then in here, let's go GUI input, and the if event is input event mouse button, and then if event button index equals mouse button left, and event is pressed. We're going to get slot index from coords and get global mouse position. So now let's run this thing and see if it works. Let's click on this thing, and as you can see, nothing is happening. And the reason for that is our item slots, our inventory slots, are blocking input. And to fix that, we're gonna go into our inventory slot scene, and in here we're going to click on the mouse and say ignore. And then in here as well, we're gonna do the same. Mouse, filter, ignore. Now let's go back to our main and let's run it again. Let's click on the slots, and as you can see, we are printing the coordinates of each slot. So we click on the first one and the coordinates are 0, 0. Next one is 1, 0. 2, 0, 3, 0, and so on and so forth. Now our goal in here is to convert these coordinates into the index. And that index is basically going to be the index of the item in our inventory slot, in our slot data array. And to do that is pretty simple. We're just gonna create a variable that is going to be called index, and we're gonna say our coords x plus coords y multiplied by columns is going to be our index. So let's take a look at the example. Let's pick this slot number 5, which is 0, 1, 2, 3, 4, 5. Let's click on it, and it is going to give us the coordinates of 1, 1, which is the correct coordinates of this slot in our item grid. And let's try and convert these coordinates into number 5. So we're gonna start from here, we're gonna go 1 to the right, and then we need to transpose down 1, alright? And to transpose down 1, we will need to multiply it by the amount of columns, which is 4. So 1, 2, 3, 4. And here we go. Now back to the script, let's return our index in here, and before we do that, let's check if our index is greater than our dimensions, x multiplied dimensions.y, or our index is less than 0. We're going to return -1. Now next function is going to be a complete opposite of the one we just did. So func get coords from slot index. It is going to take an index, which is going to be an int, and it is going to return vector to I. Now this is going to be a pretty interesting one. So the first thing we need to do, we need to figure out our row of our index, basically of our item that we have the index of. And to do that, we're simply going to divide this index by columns. It is going to give us like how many whole columns fit in our index. Then we're gonna figure out our column, which is going to be done by saying index modulo columns. And it is going to give us the remainder of this thing, the remainder of division, okay? And this is going to be our column. Now we're going to return vector to I, our global position, plus vector to I, our column multiplied by slot size, and our row multiplied by slot size. Now let's go here and figure out if it works. Let's store our slot index in a variable that is going to be called index, and then let's print out our index and our get coords from slot index. And let's see if it works correctly. Now if you click on the first one, 0, 0, the second one, 16 and 0, 32, 0, 48, 0. Okay, it seems to work. Very nice. Now let's go ahead and create inventory items. So the first thing we're gonna do, we're gonna create a new folder that is going to be called resources. And the first thing we're gonna add is a new script that is going to be called item data, and it is going to inherit a resource. Let's create, and then here we're gonna give it a name of a class name item data, and we're gonna have a couple of things going. So the first thing we're gonna do, we're gonna create an export variable that is going to be called name, and it is going to be a string. Next one, also export variable that is going to be our texture, that is going to be texture 2D. And the last one is going to be our dimensions of our item, that is going to be vector 2i. Now let's create a new resource out of it. So let's click on resources and then create new resource, and then let's search for our item data. Let's click on it twice and let's name it item data, and let's save, and here we go. Now let's click on our inventory and let's add a script to it, and let's call it inventory. Let's place it in our script folder. Let's create, and in here we're gonna have our export var items, that is going to be array of our item data. Now the next thing we're gonna do is actually we need to create our inventory item scene, which is going to be a very simple thing because we're going to have it as a sprite 2D, and that is literally it. So let's call it inventory item. Let's save it in our scenes, and in here let's export var inventory item scene packed scene. So let's click on our main scene in here and let's drop our inventory item scene in here. Now let's create an inventory item script by clicking on the inventory item scene and adding a script to it. Let's put in a scripts folder, and let's add a first variable that is going to be data, which is going to be of the type of item data. It is going to be null by default. Next, we're gonna create a size variable that is going to be a vector 2, and it is going to have a getter that is going to return our vector 2 data dimensions x and data dimensions y multiplied by 16, which is our cell size. Then we will need to create an anchor point that is going to be our top left of our thing, of our item, and we're also going to create a getter for it, and it is going to be our global position minus our size divided by 2. Now we're gonna create a ready function in which we're gonna check if we have our data. We're gonna set our texture to our data texture. Now we're gonna create a function with which we're going to be setting our initial position and updating our anchor point. So let's call it set init position, and it is going to take in a position which is going to be a vector 2, and it's not going to be returning anything. And let's say our global position is going to be this position plus size divided by 2, because sprites 2D have offset being in the center, and we don't want to change that because in the future we're going to be rotating this around, and this offset is going to act as a pivot point for the rotation. And if we unclick the center thing, it is going to be rotating around the top left point of our item, which we don't really want. Okay, and then we're going to set our anchor point to global position minus size divided by 2. Oh, and I just realized that there was a typo in here, so it's position, not position. Okay, now let's go to our inventory and let's create a function that is going to be called add item. It is going to be taking in item data of the item data type. It is going to be returning nothing, and the first thing it is going to do, it is going to create an inventory item from the inventory item scene instantiate, and we're gonna set inventory item data to our item data, and then we're going to add it as our child inventory item, just like so. Now at this point we need to add this inventory item to our item grid, so let's do on ready var item grid is going to be grid container, and it is going to be equal to our item grid. And here we're going to say var success. It is going to be the result of our item grid attempt to add item data, and it is going to be literally just inventory item. Now this function does not exist, so let's go ahead and create it. So back in our item grid script, let's create this function func attempt to add item data, and is going to take in this item, which is going to be a node, and it is going to return a boolean. So what this function is going to do, it is going to go over each item in our slot data array and check if it is empty. I mean, if it is equal to null. If it's not, we're gonna continue iterating over until we're reaching the end or finding the empty spot. So let's make a variable that is going to keep track of our current slot index, and it is going to be an integer and is going to be 0. Then we're gonna create a while loop that is going to go while our slot index is less than our slot data size. And in this loop, we're going to be consistently checking if our item fits. And there's going to be a new function that is going to take in our slot index and the dimensions of our item. And if it does fit, we're gonna break out of our loop. Otherwise, we're going to be increasing our slot index by 1 each iteration. Now let's create this function in here. So let's say func item fits, and let's put an index, integer, and dimensions vector to I, and is going to return a boolean. And in here we're going to be iterating over our y in our dimensions y, and for each y we're going to be iterating over our x in our dimensions.x, and we're going to be checking our current index, which is going to be our index plus x plus y multiplied by columns, which we already know how to do and why. And in here, if our current index is bigger or equal to our slot data size, we're gonna be returning false, which means we are out of bounds of our grid. Or if our slot data at this current index is not equal to null, we're gonna be also returning false, which means the slot is taken. Otherwise, we're gonna be returning true. Now, back in our attempt to add item data function, we are going to check if our slot index is bigger or equal to slot data size. We're gonna return false, which means this thing went through the entirety of our slot data and have not found anything. Otherwise, we're gonna add our data to our slots, and it is going to be done simply by doing kind of the same thing we already done once. We're gonna go through the dimensions of our item. So for y in item dimensions y, for x in item data dimensions x, we're gonna set our slot data at that slot index plus x plus y multiplied by columns to our item. And then we're gonna return true, because we have succeeded in adding our item to our slot data. Now in here we might as well position our item in our grid. So let's say item set init position, and let's call our cool function get coords from slot index, and let's say slot index. And this should, in theory, just simply work. So let's click on our inventory and add an item in here to our item array, which I just realized just called item instead of items. We're gonna change that in a second. Let's add a new item, let's give it some random name, and in our asset folder there should be an orange square, which is 32 by 32 pixels, which means its dimensions are 2 by 2 because one slot is 16 pixels. And then in our inventory script, let's first of all rename this, add as to that. Here we go. Actually, just reset the entire thing. So let's do this entire process again. Okay. And in our onReady function in here, we are going to iterate over our items array. For I in items, we're just going to add item I. And in theory, this should just simply work. And it didn't because I made another typo. What a surprise. What a surprise. Let's try again. And as you can see, we have our item positioned correctly. Very good. Very nice. Now let's add one more item, and this item is going to be a new item data in here and some other random name, and let's pick this blue one. And this one is vertical or horizontal or whatever, and it has the dimensions of 2 by 1. Okay, let's run this again, and here we go. Look at this. index. Amazing. But now we're gonna have a little bit of a problem. If we're gonna go into our item grid and change our X dimensions to 3 instead of 4 and run this thing again, you're gonna see the issue here that our blue item is poking out, which is an issue. And to fix that, we're gonna go back in our item grid script, and in our item fits function, we're gonna add another if statement. And for that if statement, we need to create a variable that is going to be called split, okay? And it is going to check whether our index divided by columns is not equal to our index plus x divided by columns. And if it is split, we're gonna return false. And what we're checking in here, the split thing, is basically whether our x, basically width-wise slots, are in the same row as our original slot. So let's run this thing again, and here we go. Now it's positioned correctly. Amazing. And if we want to see how the actual thing is working, we can take a look in our remote view on our item grid. You can click on our slot data and see how items are situated. So this is how this data looks like in our slot data array. You can take a look at this orange square in here and see that it takes up slot number 0, 1, 3 and 4. And in here, in our slot data array, we can see 0, 1, 3 and 4, and each one of those should be orange squares. Now let's try to make it so we can pick these items up and place it somewhere else. So let's go in our inventory item script, and in here we're gonna add new variable that is going to be called isPicked. It is going to be a boolean, and it is going to be false by default. Now in here, we're gonna create a process function in which we are going to be checking if is picked, and here we're going to be setting our global position to our get global mouse position. Now let's create another function in here that is going to be called get picked up, and it's not going to take anything, and it is not going to return anything either. Now the first thing we're going to do in this function is we're going to add ourselves to group of held item. Then we're gonna set our isPicked to true. Then we're gonna set our z index to something bigger than 1, and we need to update our anchor point to global position minus size divided by 2. Now in our item grid script, in our GUI input function, let's delete this print statement, and let's say the following. So let's make a variable held item that is going to be get tree get first node in group held item. If we don't have held item, we're gonna detect which slot we are clicking on by saying get slot index from coords, and it is going to be our get global mouse position as our position. Then we're gonna detect the item in this slot, so slot data slot index. If no item, we're gonna return, which means the slot is empty. Otherwise, we're gonna say item get picked up, and that's about it. Now let's run this thing, and as you can see, we can pick up the item. Amazing, but we cannot place it down. And also, there's another issue, and we still have this item being in our inventory, which is not good. So let's go ahead and create a function in here in our item grid script that is going to be called remove item from slot data. And it is going to take in our item as a node, and it's simply going to iterate over our slot data size, and it is going to check if our slot data I is going to be equal to our item. We're gonna set our slot data I to null. Now let's use this function here, remove item from slot data, and let's put in item, and let's run this thing and check if it works. Let's pick this orange square up, and let's then go into our item grid in our remote view and check our slot data array, and as you can see, it is empty. Very good. So now let's work on placing this item down. So the first thing we're gonna do, we're gonna move this index variable inside of this if statement, and then in here we're gonna say else, which means we do have held item in our hands. And let's do the same kind of thing, var index get slot index from coords, and this time it is going to be held item anchor point position. And in here we're gonna also figure out if we have an item in here by saying slot data index, and if we do have an item in there, we're gonna return. Otherwise we're gonna say held item get placed, and here we're gonna pass get coords from slot index, and it is going to be our index. x. Now this getPlaced function doesn't exist, so let's go ahead in our inventory item script and let's create it. So let's say getPlaced, and it's going to take in a position, which is going to be vector 2i. It is not going to return anything, and the first thing it's going to do, it is going to say is picked. We need to set it to false. We need to set our global position to position plus our vector 2i size divided by 2. We need to reset our z index back to 0, and we need to update our anchor point to our global position minus size divided by 2. And lastly, we need to remove ourselves from the group of held item. Now let's try and run this thing. Let's pick up this orange square and let's try and place it in here. And it kind of works. But no, we cannot pick it up because we have not updated our slot data with our new item data that we just placed in. So let's go back to our item grid script, and in here, right under remove item from slot data, let's create a very similar function that is going to be called add item to slot data. And it is going to take in an index, and it is going to take an item, which is going to be a node. Now in here, we're going to do a very similar thing. We're going to go over our y in our item data dimensions y, and for each y, we're going to go over x in our item data dimensions dot x, and we're going to set our slot data item at our index plus x plus y multiplied by columns to our item. Now let's add this function in here after we call getPlaced on our held item. So add item to slot data, and our index is going to be index and our item is going to be held item. And let's run this thing and see if it works. Now we should be able to place it down and pick it up again. So let's place it in here. Let's pick it up again, place it in here, pick it up again, place it in here. Let's take a look at our inventory grid slot data array, and we can even see it in real time. Wow. But now there's going to be a problem in here that we will be able to still place the item on top of the other item if we are not directly clicking on that item with another item. I hope that made sense. So let's try and place this orange square on top of our blue one, and as you can see, that's what's happening, and it is not great. So to fix that, we're going to go into our item grid script and create a new function that is going to be called items in area, and it is going to take in an index that is going to be an integer and item dimensions that is going to be vector 2i, and it is going to return an array. And the first thing we're going to do, we're going to create a variable that is going to keep track of our items, and it is going to be a dictionary, and it is going to act as a hash table or whatever, and we're going to iterate over our dimensions, item dimensions y, and for x in item dimensions x, and we're gonna figure out our current slot index, which is going to be our index plus x plus y multiplied by columns, you know the drill, and we're gonna figure out the item at that slot index in our slot data, and if there is no item at that spot, we're gonna continue iterating. Otherwise, if this item is not in our items dictionary, we're gonna add this item to our items dictionary by just saying items item equals something like true or whatever. And lastly, we're going to return the keys of our items dictionary if our items dictionary has any size. Else, we're gonna return an empty array. Okay, this hopefully should work. So now let's go in here, and instead of just checking for the item like this, we're gonna replace this with items in area with our index and our held item.data.dimensions. Now let's change the name of this variable to items, and in here in items, and instead of items, we're gonna check for items size. And now if we're gonna run this thing, hopefully we will not be able to place the item on top of the other item. And here we go. Now let's make it so we can swap the items around. And it's actually pretty simple. So in here, when we check for the size of our items array, we're gonna check if our items size is equal to 1, which means we're trying to place the item on top of only one item. So what we're gonna do, we're gonna say held item dot get placed, and here we're gonna say get coords from slot index, and it is going to be our index. Then we're gonna remove item from slot data, that is going to be the first element and the only one in our items array. Then we're going to add item to slot data, which is going to be at our index, it is going to be our held item, and then the first first element in our items array, we're gonna call getPickedUp. And honestly, that should be it. So let's see, let's pick up this blue and let's try and place it in here, and here we go. Look at this, we can switch between items and we can place them around. And if we take a look at our slot data in our remote view, we're gonna see that it magically just works. How about that? Now let's go ahead and add a rotation. So let's go into our item data resource thingamajig and let's create a variable that is going to be called isRotated. It is going to be a boolean and it is going to be false. Now in our inventory item script here at the bottom, let's create a function that is going to be called doRotation. It's going to be void, and the first thing it's going to do is going to set our isRotated variable to the opposite of whatever it is. Then we need to flip our dimensions to new dimensions, which are going to be data dimensions y in the place of our previous data dimensions x, and data dimensions x in the place of our previous data dimensions y. Now to better visualize rotation, we're gonna create a tween, and then we're gonna tween our tween property that is going to be on our self, and a rotation degrees, and it's going to be 90 if data is rotated, else it is going to be 0, and the duration is going to be like, I don't know, 0.3 seconds. Now we need to use this function, and we're going to use it in our func input and build function, and we're gonna check if event is input mouse button, if event button index is going to equal to mouse button right, and if our event is pressed. If we are picked, we're gonna do rotation, and at this point hopefully it should work. So let's pick this blue square and right click, and here we go. The only issue in here is that you have to be mega precise with your placement, and it is very easy to fix, so let's do that. So all we need to do is we need to go back into our item grid script, and in here, when we are trying to place our item, let's create a variable that is going to be called offset, and it is going to be a vector 2 of our slot size, and our slot size divided by 2. And then when we are trying to figure out the index, when we want to position our held item, we're gonna add this offset to our item position. And now when we run this thing, it should be easier to place items. Now you don't have to be that much precise. But now this thing introduced a new issue. When we click a little bit off the grid, we can do this, which is not great. So let's go ahead and create a new variable in our item grid script, and it is going to be called var held item intersects. It is going to be a boolean, it is going to be false by default. And then we're gonna go down and create a new function that is gonna be called detect held item intersection, and it is going to take in held item as a node. It is going to return void. Now the first thing we're gonna do, we're gonna figure out the rect of our held item, which is going to be rect to held item anchor point and held item size. Then we need to figure out our rect, which is going to be rect to our global position and our size. And then we're going to figure out our intersection. That is going to be the intersection of our held item and our own rect. And we're going to get the size of this thing. Next, we're going to set the held item intersects variable to this crazy thing. So our intersection.x multiplied by intersection.y divided by held item size.x multiplied by held item size.y, and if it is bigger than 0.8. So basically we're figuring out the intersection, the size of the intersection between these two rectangles, and we're figuring out whether the size of this intersection is kind of like bigger than 80% of the size of our held item, which basically means whether our item is 80% inside of our grid. So let's use this function in our GUI input function in here, and let's add in here another if statement. If event is input event mouse motion, okay? If, let's say, held item is going to be get tree get first node and group held item. If we do have held item, let's detect our item intersection of our held item. Now in here, when we are trying to place the item, we're gonna say if no held item intersects, we're gonna return, and hopefully it should fix all of our problems. So let's grab this guy and let's try and put it somewhere, and it doesn't work. Amazing. So now we made fully functioning inventory with rotating items. How about that? It looks ugly as heck, but that's not the point. Now I have fiddled with some settings and added more items, and we can see the final result. Here we go. We can place items around, rotate them, and place them on top of each other, and that's just amazing. And we cannot place them on top of two items. I think that works. I think that's gonna be it. So thank you everybody for watching. I hope this helps, and I'm gonna see you in the next one. You're free to go.